All right, cool. Yeah, thanks for having us again. So we give a presentation update a little bit. So it's not a big deal that we really are late a little bit, because we are really kind of giving an update to a slide deck that has been given up last year. So we really want to share a little bit of an ongoing work from 1 year. So last year, Michael Adam, my colleague, and Sachin, also my colleague, for giving a nice introduction about an automated testing infrastructure and environment that was built in particular to test Gluster with Samba together. That was something which is still missing in the kind of Samba upstream testing environment. And they really laid out a great infrastructure which really paid off very good times. And we want to share a little bit in this presentation the results that we got from this testing, and also the problems that we were identifying, and the next steps that we want to take. So Sachin, next slide, please. So first of all, we want to go quickly through the infrastructure components, or the open source projects involved, or the tools that we were using, the way they were working together, how well this has really paid off. So that's kind of a little bit of a repeat of what was presented last year. Then we want to focus on really a couple of nice issues that basically this testing infrastructure has really identified and allowed us really to address it in a nice way, together with the upstream communities and also with the involved components like Gluster. And then in the end, of course, we also want to a little bit talk about the next steps. Next slide. So first of all, Gluster. The big thing with really all this Samba testing which is going on, this is really growing to an impressive amount of coverage, and really exploring all the most exotic bits of the components that we really implement in Samba. But there's always a little bit of lack of really testing remote file systems. So all the SMB2 testing is really mainly focusing on testing on the local file system, XFS, X4, whatever it is really mounted there. That's really great, and we really take a lot of benefit from that. But testing a clustered remote file system, that is always something which was missing. So for that reason, Gluster as a component which we are using in our downstream products in Red Hat as well, for the Red Hat cluster storage offering, for example, and also Gluster as being a component which is used in the upstream world for providing a clustered Gluster SMB storage infrastructure. It's still really quite common, although there are others which are getting a little bit more attention at the moment, like Ceph, obviously. GlusterFS is really an important tool set. There's not so much development going on, which is really relevant for our use case, but still, it's a very important piece of infrastructure that we're dealing with on a daily basis. Next slide. So Samba obviously is talking to Gluster not only over whatever a fuse mount or so, but it has a specific way of accessing the Gluster infrastructure, which is wrapped in an accessor library called GFAPI. So there's a specific VFS module that uses that infrastructure. In the meantime, there had been some new use cases getting more important from time to time, always depending on the use case, that require to use the fuse mount again. But we are shipping now a VFS GlusterFS module, which brings in some additional safeguard functionality in order to really make it reliable and really fully functional in a clustered environment. So these specific mechanisms are implemented in the VFS GlusterFS fuse module that is really dealing with complex matters like file ID, performance, specific things like the implementation for the get real file name call, and so forth. So this has been one addition. Otherwise, for using Samba here in this whole scenario, there hasn't been so many updates. So next slide. Obviously, CTDB is really sitting at the core of all our clustering. So it's not only the building block for all the cross-node IPC, so the communication between the nodes, the exchange of messages, which really keep an important role in that SMB server, the clustered TDB replication, of course, obviously, and then, of course, for a big part, the HA components, like CTDB is the tool to really monitor the sanity of the storage nodes. It's monitoring the SMBD file server, And of course, it deals with the proper availability of the public IP addresses in the cluster. So very natural. CDDB is really a crucial component here. So nothing to add here. Next slide, please. So of course, testing such a complex environment really comes with a couple of challenges, because if you're testing like in auto build or in our GitLab runners, you have a rather controlled set of machines or containers that you're dealing with. But here we really need to have multiple machines involved, because as we are a cluster, we need to deal with multiple cluster nodes, obviously. But not only we have these cluster nodes, but we also have specific clients that are used for running the tests or for laying out the whole infrastructure. Sachin will go into a bit more detail later. So we have this multiple machines. We also have multiple projects involved, like Gluster, CDB, and Samba, obviously. And we have also multiple configuration options, because when you ship a cluster volume, there's not only one choice, of course, there are many choices in order to provide the level of replicas that you have. So if you have a volume that is suited for erasure coding and using these kind of mechanisms, so you have different aspects of distribution in your cluster and so forth. So you have a rather complex set of options that you can take for setting up cluster volumes. So that's obviously also a challenge for building such an infrastructure. Next slide. What do we really need? So we really need to have a very reliable way to set up all this complex infrastructure with the specific cluster nodes, with the specific cluster volume types. This needs to be highly automated. We don't want to do it manually in any kind. We also need to think about the test runners that is really then using the cluster infrastructure in order to test whatever functionality, and then really go on with the real SMB testing, which is the core motivation, of course, for this whole infrastructure. And we also need to have a way to really not only trigger this whole machinery at our whenever we want to, but we also want to make sure that this infrastructure is really running all these testing capabilities on a periodic fashion. So, for example, we do nightly builds. We will talk about this later. But we also make this testing be triggered by just specific events taking place. For example, if we have a merge request or a pull request for GitHub, when we do some modifications for our packaging or for the list of tests that we want to run, or so, we want to really run this whole machinery and really see what the results are. These were the main requirements for really building up this infrastructure, but it turned out that this whole infrastructure is so elegantly and nicely working that it has really become very, very suitable and useful for quickly setting up a clustered environment with a specific set of configuration options. For example, when you have a customer and you're dealing with a complex customer case, some problems you need to reproduce an issue there, you can just use this machinery very quickly to enroll the set of machines that the customer has as well with the same configuration, and then try to reproduce the issue there in a way that is really much more faster than whatever rolling this out on your own. Next slide. So Sachin will continue.
Yeah, so this is the project, the GlusterSamba integration project, which is available on GitHub. We use various branches to divide the project into into different parts. The main master branch is used to contain all the Ansible playbooks required to set up our test, to bring up our test virtual machines, as well as then set up Gluster, CTDB, and Samba on them. Eventually, we also execute our test runners through the master branch. The CentOS CI branch is, it just contains a single shell script, which is used by the CI environment available with the CentOS team. This essentially just builds up the test environments, installs the right packages so that it can then execute the project, which is through the Ansible scripts available in the master branch. We also have a Samba build branch, which essentially contains the spec files and scripts required for nightly builds of the Samba packages. We will visit this again in a later slide. And then finally, we have the test branch. Now, this branch actually contains the test runners, which execute various tests, which includes simple sanity tests, which are run using the CIFS kernel module, as well as the bulk of the testing is done using the SMB torture test mechanism, which is already available with Samba. So the tools we use are the operating system we use is CentOS 7 and 8. So this used to be CentOS 7 until last week. We just changed the default to CentOS 8. One of the changes since we presented last year is we've added modifications to easily add new OSs. So this was used then to add the CentOS, add support for CentOS 8. We also use Vagrant. This is with the libvirt plugin. And we use Ansible playbooks to install, to provision these virtual machines. Now, one of the side projects we use is the Gluster Ansible project, which is a sub-project of the Gluster team. This essentially contains Ansible playbooks to set up the Gluster environment. The nightly test RPMs we built are built for both CentOS 7 and CentOS 8. These RPMs allow us to easily install the latest versions of Samba on our test virtual machines. Now, these builds are created nightly from the latest master branch on Samba. We similarly also have nightly RPMs for the Gluster packages. Now, these packages are built by the Gluster team from the spec file available in their master branch. If these files are free to download and are available at these locations.
Right, so for Samba, we are really building RPMs on a nightly fashion, as already mentioned, but it's really important to point out that we really take the Git tree from the Samba upstream repository and really create RPMs based on the master infrastructure. So that, of course, is a big difference to whatever other packaging that would just take release branches or so, but we're really taking the latest and greatest stuff. And we are packaging it with a spec file loosely based on the Fedora Rawhide package. So just some small modifications in order to get rid of some depending libraries. So that would make it a little bit more too complex. So these are a small modification. In this build branch, we basically just build the RPMs for CentOS and then run some very basic install tests, really just to make sure that there's whatever no overlap with any whatever dependencies or any other things not working properly. So just a very basic install test. One thing that we really learned, of course, over the turn of the past year is that keeping track with the fast pace of development changes in the master Git tree is really something really something that takes a lot of resources and time. In particular, because we are still really kind of tracking every single library change or whatever, if there's a new library or a library being moved or renamed, and also all the lists of the test packages for Python and for CTDB tests. So there's really a massive amount of testing infrastructure with new scripts and new things popping and getting removed every day. So there's really an enormous speed of development, and really keeping track with that is really, really a challenge. Then again, of course, this gives us really the ability to really test the latest and greatest stuff and to really catch up issues that are arising for this whole project, the integration with Gluster very early. But on the other hand, we also need probably to invest more into really looking for building release branches. So not the master tree, but for example, for 14 tests or something, to really keep track of the releases that are currently prepared in the upstream community, which then also are relevant for us as a downstream consumer instead of Red Hat for building packages for that. So right now we are investing into that, and my colleague Anoop has also almost finished implementation for this, I think, to really allow us to build not only master packages, but also packages for specific Git branches or even specific tags or hashes, something like that. Yeah. Next slide.
So yeah, let me just quickly go through how these test machines are set up. This is in the master branch. This contains the Ansible playbooks required to install these virtual machines. The information required to set up the cluster, as well as the test information, tests run against the cluster. The two informations are available in clustervars.yaml and testinfo.yaml file. So once the virtual machines are set up, we trigger these tests. So this is how it goes about. So from our host machine, we first create a setup virtual machine. Now, this is the virtual machine from where we will complete the setup of the cluster nodes, and following that, the client machines. Now, once these have been set up, we trigger the build. We trigger the test runner on the client machine, aiming at the cluster nodes. Now, this is aiming at the public IP address, which is exported, exported using CTDB. So there have been several improvements to the setup. This includes better error reporting, multiple OS support. You can install both CentOS 7 and CentOS 8, which is now the default. We've also made it idempotent in the sense if we have to make any changes, we do not need to perform all the tasks again. We just need to, we simply run the Ansible playbooks, which simply makes these changes which are required. So yeah. Also, additional documents. So one of the advantages I found with the system is I could quickly use it to set up test environments. But there were certain issues with that, in the sense things like setting up SSH, initially we were running this on a separate machine, since this was designed to be run as part of a CI infrastructure. This code, we had to jump through a few more hoops to get it to be easily accessible for a developer. So whenever we had customer issues, I found myself using this particular project to quickly set up test environments on which I can then try and reproduce the problem. And also, I needed to set up build environments on these. So in case I needed to add instrumentation or make changes and quickly test them, I could do that using this project itself. Now, there are some, I've added documents in the /doc folder. Now, these are added based on our experiences running them as a test environment for customer issues. So there are also additional playbooks in the /devel environment. Now, these are for ease of access, such as setting up SSH, and also for setting up a build environment. Now, this currently works only for CentOS 7. We just switched the default, so we should have support for CentOS 8 really soon. So this is a quick demo of the test environment. So I just want to show people how I run this on my Fedora desktop machine. Now, in this particular case, I'm using Fedora 33. We start off with the user test. Now, this user has both access to sudo, so it's part of the wheel group, and has access, is part of the libvirt directory, which libvirt group, which allows it to create virtual machines. So simply fetch the Git repo and call make from the repo. Now, what this does is it creates the required Vagrant file, and it executes Vagrant to install these test virtual machines. Now, there are 4 virtual machines which are created. It takes about 15 to 20 minutes. This is on my laptop. So it ends with a client test run. Now, I've just snipped these videos so we can move forward quickly. So in this case, the virtual machines have been created. This is the list of the virtual machines running on my laptop at the moment. Next, I need to be able to access them. So I first make sure that the entries are available in the etc host file. Now all this information is available on readmes in the /docs directory. Then I go to the devel directory and I simply call another Ansible playbook which fixes the SSH. But before I call the playbook, I just need to create an authorized keys file which copies my public key to these test VMs. What this does is it changes the SSHD configuration to allow root access. It changes the root password to a simple password, X in this case, and it copies the authorized keys file. Now it does this for all the virtual machines. Now once it is set up, again just confirming etc hosts, and then I should be able to SSH into into storage 0, which is one of the cluster nodes. Once in here, I can look at all the Gluster volumes which have been installed. Now, if you notice, there are 3 volumes. For the first one is the CTDB volume, which is used by the CTDB for its log. And then we also create a disperse volume and a replicate volume. Now, these are the 2 most common volume types which are installed by GlusterFS users. So that's what we have set up on the Gluster environment. Now, these volumes are exported by Samba. You can also get more information about the volumes by running a Gluster volume info and the volume name. So this is the disperse volume, and we do the same with the replicate volume. Yeah. Once you can also manually test, run the test infrastructure by simply calling make client1.test. Now this runs the test infrastructure. And once you have been, once you're done, you can clean up by simply calling make clean.
So obviously, I think there's not really much to see when you run make client test.
The information, there's actually not much logs which are shown for a successful run, but in case of an error, the entire error information is provided on the screen. Mm-hmm. So here we have cleaned up. We've cleaned up the test machines, and we're just listing there are no more virtual machines running at this moment. Okay, the next branch, which is the test branch, this is executed once the nodes and the clients are set up. It contains the test runner, which runs various tests. These include simple sanity tests, which are run using the sys-kernel module, but the bulk of the testing is done using the SMB Torture test framework, which is built, which is used from the nightly RPM build, from the nightly Samba build. So the updates on the test environment. So we've added a lot more tests. We still focus on SMB2 and 3 testing. We essentially built our list by starting with a full test run and using those tests which successfully build against Gluster, which successfully run against GlusterFS. Beyond that, we are slowly going through the list and fixing all outstanding issues. Now, we copy over the self-test infrastructure from the Samba code. Now, this includes the known fail and the flapping lists. Now, one of the problems we have is we need to keep the self-test infrastructure, which includes the Perl and Python scripts, in sync with upstream. Now, at the moment, we just copy it from the Samba source tree, but it does get updated fairly quick. Fairly frequently, and we are looking at ways at minimizing this maintenance burden. Now, continuous testing has helped us identify a few critical issues, and we'd just like to go through those issues next. One of the first problems we fixed was the data corruption issue, and this is related to the right behind translator on GlusterFS. The Samba torch, this was of course identified through a Samba torture test, in this case a read-write test. Now what the test does is it opens two client connections to the server. It then proceeds to write a particular buffer of data from the first client onto a file on the server, and from the second client it reads the same it reads the data from the same file into another buffer, and it then compares the buffers. If the buffers do not match, it fails with an error. And here on the disperse volume, we were hitting an error. So trying to identify the problem a bit more, we identified it to be as part of the write behind translator. What the write behind translator does is it caches writes and immediately returns success to the application making the write call. It continues flushing the data back to the disk in the background, and it's used as performance. It's used to improve performance for clients using the GLFS API. Now, with Samba, however, the server expects the data to be flushed to the backend before the write returns successfully. Without this guarantee, there's a possibility of data corruption, which is demonstrated by this issue. So as soon as we discovered this particular problem with write behind, we tried to fix this issue by essentially the fix involves disabling the write behind translator. So what upstream now does is, if it detects when loading the VFS GlusterFS plugin, if it detects the write behind translator, it attempts to disable it automatically. Now, for this, it requires the newer version of GlusterFS. If it detects it, but it's unable to disable the translator automatically because the support was added in a later version, the Samba server refuses to connect to the Gluster volume and prints a warning in the log. In this case, the user is expected to manually disable the translator. Now, a word of caution here, the latest RHGS has this particular problem. It cannot automatically disable the translator, and it has to be manually disabled by the user. Now, we write an error message in the logs. Additional information is provided in the VFS GlusterFS man page, as well as support has been added to the loop, and we have K-base articles written for this particular case. Another issue we detected was a problem in the metadata cache. This again was in GlusterFS, and in this case, the SMB torture test used was SMB to create ACL file. Now, this involves the GlusterFS metadata translator. So it's called MD cache, which caches certain extended attributes which are used by Samba. So it improves performance when Samba is accessing the GlusterFS files. So the torture test involves setting up a DOS attribute. For setting up a DOS attribute, Samba uses an extended attribute user.dos attrib, which is to store these attributes and then reads them later. But there is a failure when the DOS attribute which is read does not contain that set attribute. The problem is the attribute is cached by MD cache, but under certain conditions, the MD cache returns a false value that there are no extended attributes set. There is no DOS attribute set. So this causes the bug we see with this SMB torture test. Once we identify the problem, we were able to isolate this. We created a reproducer using the GF API, and we provided it to the Gluster developers who quickly fixed this issue. So this has been fixed in the release versions of GlusterFS. Another place where we saw this particular problem is on Windows machines, which were trying to change permissions on files. They were changing permissions on files, but immediately on looking them up again, those permissions were not set. This was fixed by just disabling the performance cache Samba metadata option. This particular problem was because the extended attribute security.ntacl was not being fetched correctly. And then we had the pathref changes. This was first noticed sometime mid to late December when tests against nightly builds started failing. Now, pathref introduces changes, which means most file system access now happens using file handles instead of paths. It does this by opening a file with the opath flag to obtain a file descriptor. This file descriptor allows only path reference and no I/O. This particular change allows Samba to more efficiently use handle-based operations used by SMB2. More information on this is available at Ral's talk tomorrow.
I think there was a very good picture given by Jeremy today, where this new, the establishment of this new Samba VFS layer is really like changing the wings of a plane while flying. So it's really a major effort and really a tremendous amount of changes involved. And it's really no wonder that these more exotic file system backends, which are not tested in an automated fashion earlier, were not really always in the loop of really catching up with all the issues. So it's not meant to that the people working on this major effort are really not doing a perfect job, but it's really this is a good example. Such a major rewrite like this new VFS layer is really also touching file systems which are not used on such a daily basis in the daily testing, and for that reason it was really becoming an interesting challenge for us.
Hey Günther, you're welcome to help.
So first of the fixes which were identified by pathref, we had open file directory failures. It needs a specific, so Gluster has different open calls for files and directories, and to identify which call to use, it looks for the O directory flag set in the open call. Now, there was a bug in this case where the O directory flag was overwritten by the O read-only flag. So this was identified by Ralph and fixed upstream.
Can I ask a quick question about that one?
Sure.
Is there any real reason that you can't just silently map O read-only to O directory inside Gluster? Because it's such a pain, because what it means is you have to do a stat call on the path before you know the correct flags to send to open.
Yes,
and there's no reason for that whatsoever. It's just it's just a pain.
I'm not entirely sure. I'll have to check with Gluster developers, but that particular VFS stat call that was actually handled in the next slide, the one after this. No, actually, it's in here. Sorry, it's this one. Yeah, pathref changes. So we did find that problem in a second SMB torture test failure, and this again was caused due to these pathref changes, which broke the GlusterFS backend functionality. This was fixed by adding a VFS StatFS call, a VFS stat call in the mkdir path. What it does is once you obtain the stat data, we can identify that it's a directory, and then we pass the O directory flag. But yes, I do understand that particular case, but that is something which is a Gluster design decision. So it's something we need to push to them.
I think it's only just done like that because the GF API layer is kind of proposing that. So and bringing in a change that does it differently, I'm not sure if we can do this easily, but we definitely need to discuss this with Gluster engineers.
And finally, the last one, pathref changes. There were still more failures with SMB torture, and in this case, again, caused by pathref patches. It introduces so in this particular SMB torture test, mkdir is called twice, and it expects a certain error. If an unexpected error happens, it causes the test to fail. That's what happened here. In this case, the error handling code in the mkdir internal call handles the error for this particular error condition, and the error is determined by looking at the error number. Now, the changes introduced by this pathref patches, it added a resource destructor in the error handling code. When used with GlusterFS, it ends up calling other GlusterFS API calls that this particular destructor does, which ends up overwriting the error number. So the error number which it was attempting to handle has now been overwritten. It means that the error handling code which reads that error number later, is not run, and a more generic error has been returned, which is not what the SMB torture test required, and it ends up failing. So this was fixed thanks to Jeremy. We store the error number and now reset it once the destructor has done its job.
Right. So to really summarize all these things and these issues and the way that we dealt with them, that really shows that, of course, this whole testing infrastructure and this automated testing is really an enormous win, not only for the upstream project, but also for whatever our own downstream Red Hat specific QE testing, because now really regressions that might lurk into releases, they're really identified very early, and we can quickly react on this and look and inspect and research them. Of course, on the other hand, if you are in the middle of such a major rewrite like this new VFS layer and all these pathref changes, it's of course sometimes hard to distinguish, okay, is this now really a bug? Is this just maybe a patch set which is not yet fully covering all the exotic file systems like GlusterFS because they are not tested? Or is this really just work in progress? And most often we just learned that sometimes you just need to wait and see for Ralph or Jeremy's or Volker's next patch set coming around, and the next merge request will already resolve that issue that we have seen. So sometimes we see issues, we immediately jump on it, we research it, and sometimes we just learn, okay, it's already fixed. We just need to wait for the next build, for the next nightly build, and then see that everything is going on nicely again. So that really motivates us also to really focus more on testing these release branches more, and really to look into the code base, which is kind of more stabilized and matured, and really plan for the next release in order to avoid us to really spend too much time to investigate these issues that our infrastructure has found. Next slide. Yeah, so we only have a couple of minutes left, so we'll go fast here. The CentOS CI infrastructure, what does it really do? It's for us in that branch, it rolls out these builds. Every night we have the full set of Samba RPMs built based on the master branch. We have this full test coverage for the clustering test every night. Every GitHub pull request triggers a full test cluster. So if you do any modifications to the spec file, for example, or to the list of tests that we run, it will run a full test again. This testing metrics that we're working on, that Anoop in particular is looking into at the moment, that really has to deal with a couple of problems, of course, because if we test specific release branches, then we need to really take into account that the whole file layout for the packages might look different, because binaries or libraries or something like this, scripts, might not be available or be stored differently or have other names or something like this. So we have many spec files to watch after. The same also for testing, so we can't always expect that the whole test list will be the same for master tests or tests for release branch. So there might be differences there as well. Things we need to look into, like the known fail lists and so forth. So there are problems and issues that we need to investigate more on. Next slide. Yeah, the CentOS CI environment, Michael covered it nicely already last year. It's really just a very open and very powerful, very reliable testing CI infrastructure. A couple of links shared here if you want to get involved into this a little bit more. We are still in the Gluster space, so we don't have whatever made a choice to create a new Samba space or so, because the primary motivation of this whole thing is, of course, to test Gluster. So big changes here. These are the things that we are currently working on and plan to look into. Of course, tests. So Sachin will continue adding more tests, maybe enable more test suites, and yeah, definitely revisit the list of known fail tests there in order to check if there's actually still bugs there that we need to track down and research. Then this whole testing matrix, including also the testing of different share options. So we don't have only this VFS-GlusterFS VFS module, but also the Fuse module, AcaleXutter, Fuse module, many things that we really need to make sure that they're also properly working on this Gluster backend. Because in the past there have been some issues, so most of them were resolved in the meantime in upstream, but there might be still some issues there. So we need to extend the coverage for sure, and also we need to more and more realize the fact that we need to look into other distributed file systems, in particular into adding the ability to reuse this infrastructure, probably also to test Ceph. So that's, of course, a major change that we need to do there, but definitely something we need to invest. Sachin, you have anything else to add here?
Not much. Yeah, I think you've covered it well.
All right. Okay, so we are at the hour. Are there any questions? Remarks? Everyone wants to have a break, I think.
Hey, just chiming in here, it's Michael. It was commented on the chat by Volker that yeah, could have been done maybe in GitLab itself, or if you were in GitLab, then it would be maintained directly, and we didn't have this whole building problem and so on. I mean, that is right, but just to repeat what I also wrote on the chat, this is kind of a first step. It is initially Gluster focused. We try to do it all in a way that most of it is reusable. And we're adding this kind of previously untested constellations, testing a real CDDB Samba cluster on top of a real distributed file system is something that we couldn't cover yet in the GitLab CI. If we want to go somewhere, we could consider this in the future, absolutely. But for now, there's a level of indirection and a level of latency before we hear about these things. But we have reached a stage where, in principle, we could start informing about failures, about regressions that are introduced, especially when we're testing the test branches for the releases, whether to inform the, I don't know, Samba technical list about such regressions or something. This is the next step that we might do before we really try and integrate it directly. So just that comment.
All right.
Right. Thank you.
Yep. Thank you.